In this video, we're going to be doing lesson 5.5, which is on solving quadratics by factoring. And you probably learned how to factor in Algebra 1, but you may have forgotten or you may have missed it somehow. So we're going to review that and do some of those factoring techniques today. So the first way we're going to factor is when there's not a number in front of the x squared. These are the easiest ones. You'll get really good at these. So when we factor, first of all, it has to be set equal to 0. Everything has to be on the same side of the equal sign in order to do this. And then it needs to be in the correct order. Your x squared first, then your x, and then your constant or your plain number. So in this one, remember your a is 1, b is negative 10, c is 21. And we're looking for two numbers that multiply to be c and add to be b. So in example 1, and I will do this X method, it really doesn't do anything except organize your numbers. So we're going to put 21 on top, negative 10 on bottom. We're looking for two numbers that multiply to be 21, but when I add them, I get negative 10. So if you're having trouble, let's just write down all of the ways that we can get 21. 1 and 21, 3 and 10. And that's it. Or not 3 and 10, 3 and 7. Whew. Okay. So of these, if I add all of these, I'm going to get a positive 22 or a positive 10. My goal is to get a negative 10. If I make both of these negative, when you multiply a negative times a negative, you're still going to get a positive 21. But when I add negative 3 and negative 7, I get negative 10. So we found our two numbers. We're going to take those two numbers and we're going to write them into factors. So it's going to be x minus 3, because that was a negative 3, and x minus 7, because that's a negative 7. If we were just factoring, which is what you did in Algebra 1, this would be your final answer. But in quadratics, and when we're talking about parabolas and we're looking for x-intercepts, we have to take it a step further. We have to take each set of parentheses or each factor and set them equal to 0 themselves. And then we solve. So over here, I would add 3 to both sides to get x equals 3. And here I would add 7.
Excuse the interruption. We need all volleyball team members to report to the art room.
Sorry about that. So we get x equals 3 and x equals 7. You're going to find that with these examples, it's always the opposite, like positive 3, positive 7. But please do not just write that down, because when we get to the examples on the back, it's not going to be that way. So you've got to get in the habit of knowing whenever it's factored, you take each factor and set each factor equal to 0. So number 2, we're looking for two numbers that multiply to be 15 and add to be 8. If you know those numbers, go ahead and write those in. If not, we can go try to figure those out. 1 and 15, 3 and 5, that's it. So of those, 3 and 5 add to be 8. So my factors are going to be x plus 3 and x plus 5. You're going to take x plus 3 equals 0. I expect to see this on your paper, at least this. And so that means if I were to subtract 3 from both sides, I would get x equals negative 3. And over here, if I subtract 5, I get x equals negative 5. Number 5, notice it's not set equal to 0. So I've got to subtract 80 from both sides to make that 0. And we'll get x squared plus 2x minus 80 equals 0. There weren't any other like terms to put with the 80 because it didn't have an x and it didn't have an x squared, so we just write it there at the end. And so now we're looking for two numbers that multiply to be negative 80, but add to be 2. So yeah, I know it's a negative 80, but I'm just going to think of the ways to get positive 80, and I'm going to remember in my head that one of the two numbers has to be negative. So we have 1 and 80, 2 and 40. So think of all the ways. Take 80 divided by 3, 80 divided by 4, 80 divided by 5, and figure those up. So 5 and 16. 6 doesn't go, 7 doesn't go, 8 and 10. So because this is a negative 80, one of the two numbers has to be negative, and when I add those two numbers, I get 2. So try to figure those out. You should get 8 and negative 10. Oh, sorry, positive, that's a positive 2. So positive 10 and negative 8. If you multiply these two numbers, you get negative 80. If you add these two numbers, you get positive 2. So we write them in our factors, and then we set each factor equal to 0. If you want to check your answer, if you go to y equals x squared plus 2x minus 80, and if you look at the graph, it should cross at 8 and negative 10. And it does cross at negative 10 and 8, so that's correct. Number 6, it's not set equal to 0, so we need to subtract x from both sides, and we need to subtract 4 from both sides. So we get x squared. 11x minus x is 10x. And 29 minus 4 is 25. So we're looking for two numbers that multiply to be 25, but when I add them, I get 10. If you know those numbers, go ahead and write them in. If not, think about all of the ways you can get 25. 1 and 25, 5 and 5, and that's it. So of those, if I do 5 plus 5, I get 10. So we write in factors. X plus 5 equals 0. And if I subtract 5 from both sides, we're going to get x equals negative 5. Because these factors are the same, you don't need to do it twice. You actually only have one x-intercept. See how that parabola sits on negative 5. Sometimes you will see this written as x plus 5 squared. So now we're going to get into some of the problems that are a little bit more difficult. The ones that have the number in front of x squared. And those are quite a bit harder because there's a lot more steps to do. So it's very important that you follow all of these directions. The way that you solve them is quite a bit different than the front. So you've got to follow these steps. So step 1, make sure the quadratic is set equal to 0. And if there's a GCF, we need to factor that out. But there's no GCF, nothing that these three have in common, and it's set equal to 0. So we're going to go to the side, and we're going to create a 2 by 2 box. Make sure you leave some room on the top and the left side. There are lots of different methods for doing these. You'll learn, you may have learned a different method in Algebra 1. You may see a different method in Advanced Topics or in Algebra 3. I'm just showing you the one that I prefer. All right. So step 3 says to place your ax squared in the top left. So 5x squared, and your c in the bottom. Then it says to multiply your a times c. So 5 times negative 2 is negative 10. We are going to look for two numbers that multiply to be this negative 10, but add to be our b value, which is negative 3. So we want two numbers. We want it to multiply to be negative 10, which means one of our numbers is positive, one is negative. So we could have 1 and 10 or 2 and 5. And of those, one is positive, one is negative. So how do we add to get negative 3? Well, if we do a positive 2 and a negative 5, we'll get negative 3. So we take that 2, the 2 and negative 5 can go in either box that you want. So it doesn't matter. And you also put an x with it. So we have 2x and negative 5x. You can switch, it doesn't matter. And then we go to step 6. Find the GCF of each row and each column. And that's going to give us our factors. So let's look at this first column. It doesn't really matter which one you do first. What is the GCF? What do 5x squared and negative 5x have in common? Well, I can divide them both by 5, and they both have an x in common. What about this column? 2x and negative 2. They both can be divided by 2. They do not both have an x, so it's just 2. What about this row? What do 5x squared and 2x have in common? 5 and 2 cannot be divided by anything except 1, but they do both have an x in common. Now what about these two? Negative 5, negative 2, can't divide them by anything, and they don't have an x in common. So typically, we would put a 1 here. However, one rule that you have to remember, if the very first number is negative, then what you write out here has to be negative. So we're going to write out a negative 1. This rule is if the first one. So the one on the left if you're doing rows, or the one on the top if you're looking at the columns. And so those are my factors. 5x plus 2 and x minus 1. And so then we'll take 5x plus 2 and set that equal to 0. And x minus 1 equals 0. And we just have a two-step equation. So if I subtract 2 from both sides, we will get 5x equals negative 2. And then if we divide by 5, we get x equals negative 2/5. Now, if you want to write that as a decimal, you can write it as negative 0.4. But I prefer a fraction. And then this one, if we have x minus 1 equals 0, we need to add 1 to both sides, leaving us with x equals 1. Now let's look at this on the graph. 5x squared minus 3x minus 2. So it definitely crosses at 1, and it does cross somewhere between 0 and 1. I use my trace button. I can get pretty close. It's close to negative 0.4. Remember, the trace button doesn't get you right on it. But negative 0.4 is correct. If my graph crossed somewhere like way over here, then I would definitely know that I was wrong. But you can always look at the graph to kind of gauge to see if you have the right answers. Because remember, these that we get, those are the x-intercepts. Let's go to number 2. We're going to go back to these steps. Read the steps, follow the steps. Step 1, make sure the quadratic is set equal to 0. Check. Factor out a GCF if necessary. Is there anything that I can divide 3, 13, and 30 by? Don't say 3 because you cannot divide 13 by 3. There's actually nothing that they all have in common. So there's no GCF. Step 2, create a 2 by 2 box. Place your ax squared in the top left and your c in the bottom right. Once you have this process memorized, it will go really quickly. Then we're going to multiply my a and c. We're going to get negative 90. 3 and negative 30. So we're looking for two numbers that multiply to be negative 90, but add to be my b value. So they're going to add to be negative 13. Sometimes you will know those numbers right off, and you don't have to make this t-table. This is only to help us look for these two magic numbers. So if we just take 90, well, I know 1 and 90. 90 divided by 2. 90 divided by 3. And if you find your numbers halfway through, you don't have to write out everything. You can stop. 4 is not going to go in there. 90 divided by 5. 6 and 15. So we've got some options here. Let's see if any of these, if I add them, do I get negative 13? And because this is a negative 90, that means one or the other have to be negative. Well, I know that 5 and 18 are 13 apart. So if I make this a negative 18, 5 plus negative 18, that does give me negative 13. So 5x and negative 18x. So step 6 is to find the GCF of each row and each column. So if we look at this first column, what can I divide 3 and 18 by? 3. They both can have a 3. And they both have an x in common. Not an x squared. This one doesn't have an x squared. It only has an x. What about 5 and 30? We can divide them both by 5. They both do not have an x. And actually, when you do these problems, your first one will always have an x. Your second one will just be a number. It's kind of a good thing to keep in mind because that's the only types of problems that you're going to have. 3x squared and 5x. Is there anything that you can divide both 3 and 5 by? There's not. So, but they do have an x in common. And then 18 and 30, what can you divide both of those numbers by? We can divide them both by 6, but because my very first box was negative, I have to make sure that that one is also negative. So these become my factors. 3x plus 5 and x minus 6. So my first one, when I set that equal to 0, we first subtract 5, giving us 3x equals negative 5. And then we divide by 3. X equals negative 5 over 3. And then x minus 6 equals 0. If we add 6, we get x equals 6. Oops. All right, so if we, let me see if I can think about. All right, here's something I had forgotten about until I was just getting ready to do this. If we hit trace, we can type in a number, and that's going to take us to that x value. So let's type in negative 5 over 3 and hit enter. And we'll notice that y is 0 there. That is our x-intercept. So that's a way you can check. And if we hit trace again, and we type in a 6, that is our other x-intercept. Number 3, make sure it's set equal to 0. Check. Make sure there's no GCF. We don't have one. So let's go to our box. What goes in the top left? 6x squared. What goes in the bottom right? Negative 4. Now, if I multiply these two numbers, I get negative 24. So I'm looking for two numbers that multiply to be negative 24, but add to be 5. If you know those numbers, go ahead and put those in the boxes along with an X. If not, let's see if we can figure those out. All right, 24. 1 and 24. 2 and 12. 3 and 8. 4 and 6. Once again, that is a negative 24. So one of my two numbers has to be negative. Look at those, see if you can figure it out. If I make this 3 negative and I do negative 3 plus 8, I'm going to get 5. So it's negative 3x, 8x. And then we're going to do the GCFs. What can I divide both 6 and 8 by? 2. And then x squared and x, they have an x in common. What about negative 3x and negative 4? Is there anything that we can divide 3 and 4 by? No. And they don't both have an x. So the only thing that I can pull out is going to be a negative 1. And it has to be negative because my first one in this column was negative. Now let's look at this row. What can I divide 6 and 3 by? 3. And they both do have an x. This did not have to be negative. Even though this one was negative, over here, I'm only looking at the first box in this row. And then what about down here? We can divide them both by 4. And they do not both have an x in common. So these become my factors. If I do 2x minus 1 equals 0, make sure you add 1 to both sides to get 2x equals 1. And then if we divide by 2, we get x equals 1/2. This next one, we got to set it equal to 0. Then we subtract 4, giving us 3x equals -4. And we divide by 3. So x equals -4/3. Let's look and check our answers. So if I click trace and I type in 1/2, 1/2, it does put me on the x-axis and y is 0. So that means it's an x-intercept. And -4/3, yep, that's the other one where y is 0. Number 4, this one is not set equal to 0. So we need to subtract x and subtract 21. So we're going to get 2, actually let me write that below. It'll be 2x squared minus x minus 21 equals 0. So I would like for you to pause the video and try this one on your own. All right, number 4. Let's see, you should have made your box. We should have had 2x squared and -21. We were looking for two numbers that multiply to be -42 and add to be -1. Because 2 times -21 was -42, and then the -1. Those numbers are going to be 6 and -7. So I put 6x here, -7x there. Again, you could have flipped them, the -7 and the 6. That doesn't make a difference. Let's see, when we factor this column, they have an x in common. And in this column, they have a 3 in common. This row, they have a 2x in common. And in this row, a -7. So we have x plus 3 equals 0. If we subtract 3, we get x equals -3. Two x minus 7 equals 0. We'll add 7 and then divide by 2. And then you should always check your answer. Let's check our -3. Yep. Let's check our 7/2. Yep, looks good. If you had, let's say you had picked like +3 instead of -3, notice that did not fall on the x-axis. My y is not 0. So a +3 would not be correct.